Welcome to lesson 14. So today we're going to be talking about the evaluation of algebraic expressions. So to begin with, let's start by talking about numbers and how we write them. So let's just say, let's start here. Let's say we've got a jar. And, well, that's a terrible jar. Let's say we've got a jar, pardon my drawing here, but we've got a jar, all right? And inside this jar, let's say we've got a bunch of marbles. How's that? So we'll just throw some different colors in here. We've got a bunch of marbles inside this jar, all right? And without getting too carried away here, we're just going to draw some marbles here. So we've got a bunch of marbles in the jar. And a question that we might ask is, how many marbles do we have in this jar? What is the quantity of the marbles in this jar? All right. And to answer that, it sounds simple. We'll just go through and count them up. So we count up all the marbles, and let's say we end up with 12 marbles in the jar. All right. Well, how can we express a quantity of 12 on paper? How can we write the quantity 12? And the answer is obvious. So we can write a 12 like this. Now that would symbolically tell us how many marbles we have in a jar. Anybody that understands numbers will have an idea as to the quantity of marbles in the jar, right? But the point I want to make here is that when we think of the number 12, this is only one way to write the number 12. There are actually infinite ways that we could write the number 12. All right, and they would all be equal. They would all represent, in this case, the same number of marbles in this jar. All right, so, excuse me, if we think of another way, how else could we write the number 12? Well, I might say another way to write it would be 3 times 4. That is equivalent to 12. So that is another way of expressing how many marbles are in this jar. 3 times 4. I might say, another way to express or to write the number 12 might be to write it as 11 plus 1. That might be another way to express 12, all right, on paper. We could go on. We could go on infinitely. We could say, well, it could be written as 2 times 6. You know, that also would be a 12. It could be written as 12 times 1. That would be another way. We could write it as, well, what about 24 divided by 2? That would also express 12. That would be equivalent to 12, and it would represent 12 marbles in this jar. All right. So the point is, there are many, many, many different ways to express a given number. All right. I could even use more than just 2 numbers. I might say it's equivalent to 2 times 3 times 2. That also would be equivalent to 12. Maybe we could really go wild and say, it's equivalent to, 1 plus 2 plus 2 plus 1. All of that times 2. That would also be a perfectly legitimate way to represent 12. Because this indeed is, if you add all this up, that's 6 times 2, which is 12. So this is equal to 12 still. So this expression right here is just another way of writing the number 12. All right? So in math, we have infinite ways to write any given number. I could have picked a different number besides 12 and done the same thing. So that's the first thing to recognize, that there are many ways to do this. Now, each of these ways that we have written down up here, we're going to give them a special name. When we have, all these different ways, we're going to call them expressions. All right. Let's write that down. So these are all expressions in math. All right, they're all, you might think of it as they're all expressing the number 12 in a different way. So every single one of these is its own expression. Now, since these expressions are made up of numbers, so this is a 3 and a 4 and 11 and a 1, they're all made up of numbers and only numbers, we're going to call these numerical expressions. So these are all numerical expressions, okay? They're all numerical expressions. Pretty straightforward, all right? Now we can move on from this. What we're going to talk about next is something that's called a variable. Okay, now you may have learned this in pre-algebra. I'm hoping that you did, so I'm hoping this is somewhat of a review. But a variable is not a symbol that looks like a number. It's a letter symbol. All right. So we're going to let's use the variable y in this case. So a variable is a letter from the alphabet that we plug into a mathematical expression. All right. So we might say that an expression that would include a variable would be a y plus 2. Now you might say, well, what in the world is y plus 2? I can't add that. And so we need to talk about what a variable is. A variable is like a hidden number. All right. The variable is filling in for a number that we don't necessarily know. All right. So think of it as, it's covering a number up. It's hiding a number. All right. Sometimes, and later we'll find out that our job is going to be to find out what that number is that the variable is covering. But for right now, we're just going to assume that it's covering a number that we just don't know. It's an unknown. All right. So this y plus 2 is basically saying I have something, I don't know what it is, and I'm going to add 2 to it. All right. So you can't actually solve this right now. You can't simplify it, but we can write it. And this is how we would do it. Y plus 2. All right. Some unknown quantity plus a 2. So let's say I told you, okay, this is your jar of marbles here, and we know it's got 12 in it. I've also got a jar of marbles. How many marbles do we have together? And you might say, well, I don't know how many marbles you have, Jim, but I know I have 12. So I'm just going to say, I'm going to take your number, which I don't know what it is, and I'm going to call it y. So I'm going to say y is equal to your number of marbles. Okay, I'm just going to say y is equal to your number of marbles. I know how many I have. I know I have 12. So the answer to your question is y plus 12. Okay, and I guess I won't even put this equal sign here because we can't figure that out right now because we don't know how many marbles I have, or at least you don't. But you could say the answer is going to be y plus 12, where y is the number of your marbles. All right. So that's where an example of where you would use a variable. You just plug it in and you don't know what it is. You treat it like a number, but you don't know what it stands for always. All right. So when you have an expression, and notice this is an expression, it's just like one of these expressions up here, only here we don't just have numbers. Remember, these were numerical expressions. We only had numbers that we were using up here. Here we have not only numbers, but we've also got letters or variables, unknowns. All right. So we give these a different name. These ones, we're going to call these algebraic. Algebraic expressions. Okay. And that kind of makes sense. So algebra deals with unknowns. Algebra deals with x's and y's and z's and all these unknown variables. And that's why we call it algebraic expressions when we have one of those variables in the expression. If we don't, and we just have numbers like up here, well, then we have a numerical expression. You can almost see the root word number in numerical, or numeral in numerical. So it's just dealing with numbers and numbers only. So these are numerical expressions. This one is an algebraic expression. All right? Hopefully that makes sense. Now let's move on here. We're going to really start looking at algebraic expressions. Those are the ones that are really going to be of interest to us. So let's talk about how algebraic expressions work. So we already said that when we're dealing with algebraic expressions, we're dealing with variables. So let's just pick a variable. We're going to call it x in this case. X is, we're going to call it our variable. All right. It's hiding a number. We don't know what that number is. We're just going to use x. All right. And let's say we have the algebraic expression, 4 times x. All right. How does this work? Well, so when we're dealing with variables, multiplication, addition, subtraction, it all works the same way as they work with regular numbers. The only difference is we now have a variable instead of a number. So all of our processes are the same. We can multiply a variable, we can add a variable, we can subtract or have a negative variable, we can divide by a variable, or take a variable and divide it by a number. We can do any one of those things. We could take a variable and divide it by another variable. All right. We could do all of the operations that we can do with numbers, we can do with variables as well. Now, as far as notation, how we write these, there's a couple of just minor differences. The biggest one is multiplication. So when we think multiplication with numbers, we think, okay, we could write that as 3 times 4. That's multiplication. That could be written as 3 in earlier math. We'd use the x times 4, right? 3 times 4. We don't use this anymore because that multiplication sign starts to look like a variable. It starts to look like x. So we don't actually use this one anymore, but that is another way to write multiplication. All right. Another way is to use parentheses. So we'd have something like this. This also would indicate multiplication. Remember, there's that hidden multiplication sign between those two. So those are 3 ways that we can write multiplication when we're just dealing with numerical expressions. We're just dealing with numbers. If we're going to deal with variables, all of these still apply for variables. So I could also say 3 times x. That's how you'd write multiplication. Now, this one I would not recommend ever doing, but in theory, you could do 3 times x still, but you can see how confusing that gets, so never do it. And then you could also have, a 3 times x like this, right? Now, there is one other way that we can write multiplication when we have variables. The last way is to write it as a hidden operation, a hidden multiplication sign, and just write it as 3x. So when you see a number right next to a variable, know that there is a hidden multiplication sign between these two. It's hidden. It's kind of like the parenthesis rule. There's just this hidden multiplication sign between those two digits here, the 3 times the x. All right. So bear that in mind. That is another way to write multiplication. So again, if you ever see a number like, 15x, that stands for 15 times x, right? If you see 2 variables in a row, x, y, that stands for x times a y. All right, there's an invisible multiplication sign when they're right next to each other. Now, the only reason we don't use this with numbers when we're just dealing with numerical expressions, is think about how confusing that would be. If you just take a 3, put it next to a 4, that does not mean 3 times 4. That actually means 34. That's the number 34. If we were to try to do that, it'd be very confusing. You wouldn't be able to tell what this was. Is it 34 or is it 3 times 4, right? So we don't use that when we're dealing with numerical expressions. But when we have a variable, it's okay to do it because this is obviously 3 times x. There's no 30x. It's 3 times x. All right. So hopefully that makes sense. Let's see here. Let's move on. And let's try to evaluate some numerical expressions. So that's the next step here. So when we say evaluate, okay, what we're trying to do, whoops, pardon my button there, we're trying to find the value for a algebraic expression. All right, so and this we could do with numerical expressions too. If I have that numerical expression of 6 plus 2, plus 1, this is a numerical expression. Okay, it does have a value. What's the value? The value is the simplification of this. All right, it's where we write it as one numeral, not as a bunch of numerals with operations between them. So here we could say 6 plus 2 is 8, 8 plus 1 is 9. The value of this expression is a 9. All right, so this is our value of the expression. This is the expression. And again, in this case, this is going to be a numerical expression, and this is our value. All right. So same thing applies with algebraic expressions, but let's try to evaluate some of those. So if I have, 6 plus an x, and I tell you, evaluate that. What I'm asking for is, what does this equal? What single digit, single number does this equal? And you might say, well, I have no idea. I don't know what that x is. So in order to evaluate algebraic expressions, there's something that we need. And what we need to know is the value for x. So if I have x, and I'm going to tell you in this case that the x has a value of, let's say, 2. All right, so I'm going to say evaluate if, or given, x is equal to 2. All right, so here 6 plus x is equal to 6. Now I'm just going to fill it in. Actually, let's write it right below. We're going to say 6 plus, now what's the x? What's the value of x? Well, it's 2. So I'm just in parentheses, I'm going to fill in, I'm going to plug in that 2 in the place of that x. All right, so 6 plus 2, and the answer to that is 8. So the value of 6 plus x, if x is equal to 2, is going to be 8. All right. So if we're told what the variable is equal to, we can then solve for this. Okay, so hopefully that makes sense. So let's try another one. Let's say we've got let's do a bunch of variables here. Let's say we have the expression, well, let's say I go evaluate given x is, oh, let's make x 3 this time, y is 2, and m is 1. All right, and then our expression is going to be, oh, let's go 2xm plus y minus m, something like this. All right, so this again, this is our algebraic expression. Whoops, if I can spell it here. Algebraic expression. And these are the values that they're telling us. Our variables, remember these are called our variables. These are good terms to keep in mind. These are variables. They're telling us the variables x, y, and m are equal to these numbers. All right. So all we have to do is plug in what we know about x, m, and y. All right, so we have a 2. We're just going to rewrite that. Now, I'm going to plug these in by using parentheses. All right, so where the x is, I'm going to put a parenthesis. I'm going to fill in what x is and put it inside that parenthesis. And then I'm going to have an m. So another thing I need to plug in. Then I have my plus sign, and then I have another set of parentheses for the y, and then I have a minus sign, and then I have another set of parentheses for the m. So think of those parentheses as like holders, all right? They're going to hold the values for these variables, all right? So what's the value of x? Well, they told us it's 3, so we're going to put a 3 in here. What's the value of m? They told us it's 1, so we're going to put a 1 in there. The value of y, they told us it's a 2, so we're going to put the 2 in here. And then we have the value of an m, which again is 1. That m is going to stay equal to 1 throughout the entire expression. Whenever you're dealing with these, it is not possible that the m could be a 1 here and a 2 or something else here. They're always going to be the same. It has to be consistent throughout the entire expression. So any m in this expression is going to be equal to a 1. Any y is going to be equal to a 2. Any x is going to be equal to a 3. All right. So knowing all of that, we can now start to solve this. And we see there's multiplication involved here. We've got multiplication between these. So let's do those first. So we have 2 times 3 is 6. 6 times 1 is, of course, 6. And then we have our plus. In this case, we can drop the parentheses, plus 2. And then we have a minus 1. So I have a 6 plus 2 is an 8. 8 minus a 1 is a 7. So we have our solution, or our value for this algebraic expression. It's going to be equal to 7. That's the value of the expression. All right. So hopefully you see how that works. Let's try another one here. Let's try to complicate things a little bit. I might just pull this one right out of your book. Let's see. What if we've got, and let's go to a new page here. Give us some room. Let's say we've got the algebraic expression negative x minus a negative a plus b. All right. And I'm going to say evaluate that if x is equal to 2, a is equal to a negative 4, and b is equal to a negative 6. So we've got some negative values in here. That always makes it interesting. Let's go ahead and evaluate this. So again, I'm going to start by just rewriting it. But anywhere I see a variable, I'm going to set a set of parentheses. And in that set of parentheses, I'm going to place the value for that variable. So this is an x, the value was a 2. So we put that 2 in there. Then we have our minus sign, bring that down. We have a parenthesis. And now this is where it gets a little bit interesting, because this can get kind of messy, because we're trying to put parentheses in where we have variables, but the original expression also has parentheses in it. So we can end up with a lot of parentheses all over the place. So what I need to do is recognize that I'm going to set a set of parentheses here, and I'm going to end up with a bunch of parentheses within parentheses. So down here, just to make it a little neater, I'm going to use a different set of parentheses here, you might say. I'm going to use a set of brackets. All right. So I've got a set of bracket. I'm just replacing this parenthesis is getting replaced with this bracket. Okay. So hopefully you can see that. And then I'm going to continue. I'm going to have my minus, and then I'm going to have my set of parentheses here for the a. Now the a is a negative 4. So inside we're going to write a negative 4. All right. Then I have a plus sign. And then I have a set of parentheses for my b, and my b is a negative 6, so I'll write a negative 6 in there. And then I have my closing parenthesis here, which I've replaced with a bracket. So this is going to be my closing bracket. So do you see how that makes it a little neater? I don't have a bunch of parentheses all over the place here. I've got 2 sets within a set of brackets. Okay. So in a sense, this parenthesis got upgraded to a bracket because we knew there was going to be parentheses within this set of parentheses. All right. So now that we're at this point. Now it's review. We're just simplifying this. All right. So we have our -2. And now I can see that this has got nothing going on the outside. So we can just write this as a -2. We have a minus. And then we have our bracket. Now, what's a negative? -4. -4 is going to be a +4. So we can just write that as a 4. Then we have our plus sign. So we write our plus. And we have our -6. So I might even drop that plus sign out and just say I have a plus and I have a -6. That's going to equate to a -6, right? The plus and the negative is going to overpower the plus, and we have a -6. All right, so we have our ending bracket. We can now take it one step further and solve for our brackets. 4 minus 6 is a -2. And from here, we can say we've got a -2 minus a -2, which then turns that into a +2. All right, and a -2 plus a 2 is a 0. So we end up with a 0 as our final answer here. That is the value for this expression, this algebraic expression. All right, great. Let's do another one. Let's say we've got x minus a y. And let's say if x is equal to a -2, y is equal to 3, and a is equal to a -4. All right, let's plug them in. So we have our expression. We have our x. We're going to fill that in. We're going to start with a set of parentheses for the x. The x is a -2. We have our minus sign. We have a y. Y is a 3. So we'll just plug in parentheses, that 3. All right. Now we have a parenthesis. And since we know we're filling in other variables here, that parenthesis is going to upgrade to a bracket. So we'll just upgrade it to a bracket. Then we have our negative sign. We have an a, which is a -4. Okay. Then I have a plus sign, and I have the x, which is a -2. And then I have my closing parenthesis, which is now a closing bracket. All right. Now it's again down to just simplifying. So we have a -2 minus 3 times the bracket here. A -4 is going to be a +4 plus a -2. The negative is going to win. So we end up with a -2. All right. Now we can simplify the brackets. So we have a -2, -3 still. The brackets, 4 minus 2 is going to be a 2. And we know that this has an invisible multiplication sign here. So we have the 2 in the brackets being multiplied by a 3, but not just a 3, by a -3. So what's a -3 times a 2? That's going to be a -6. So we have our original -2 here. We'll have to rewrite, but then this -3 times a 2 is going to be a -6. So now we have a -2 and or plus a -6 is going to equal a -8. All right, and that is our solution. That is our value for the algebraic expression. All right, let's try another one here. Just moving along. All right, if, excuse me, m equals 2, x equals a -3, and a is equal to a -4. All right, why don't you pause the video here and try to do this yourself. Try to solve this or simplify this, or I should really say evaluate this. And once you've got your answer, unpause the video and we'll do it together. All right, so hopefully you worked your way through this problem and it wasn't too difficult for you, but let's go through it. So we have our negative sign. Now we have a parenthesis. We're going to upgrade that to a bracket. All right, we have an m, which is a 2. So in the set of parentheses, we're going to put that 2. Then we have our plus sign. Then we have our x, which is a negative 3. So we're going to put that in parentheses. Then we have a parenthesis here, which becomes our closing bracket. Then we're going to have another opening bracket here for our next parenthesis. And we have a negative sign, followed by an a, which is a negative 4, plus an m, which is a negative 3, times an x, which is also, oh, I'm sorry, let me back that up. M isn't a negative 3, m is a 2. Followed by, multiplied by the x, which is the negative 3, and then our closing bracket. So there we've got everything plugged in. Now we just need to simplify. So the first set of brackets here, well, we've got this negative sign on the outside of them, but to simplify the inside, we have a 2 plus a negative 3, which would be a 2 minus 3, because that plus negative 3 is going to become a negative 3. So 2 minus 3 is going to be a minus 1. That's the first set of brackets. The second set of brackets, I've got a negative 4, which is going to convert to a positive 4, plus, now here I have multiplication. I've got 2 times a negative 3. So what's 2 times a negative 3? It's a negative 6. So it's going to be plus a negative 6, which again is just going to turn into 4 minus 6, right? 4 minus 6 bracket. Okay. Now we can simplify these even further. We have our negative. This one is still a negative 1. And then we have our second bracket. 4 minus 6 is a negative 2. So now we've simplified our two brackets as far as we're able to. We can now multiply. So we have a negative. Now remember this, think of this as a negative 1 times the bracket negative 1. All right, remember whenever you have a sign outside the parenthesis or the bracket, like this, a negative sign outside of that, just think of it as having an invisible 1 right here and a multiplication sign. All right, so you'd have a negative 1 times a negative 1. Negative 1 times a negative 1, which is going to be a positive 1. And then a positive 1 times a negative 2 is going to be a negative 2. Now the way to think of that is, remember, you've got 1, 2, 3 negative signs. All of this is multiplication. This is multiplication between the brackets. So all of this is multiplication. So you have 3 negatives. That's an odd number. So you're going to have a negative answer. And then 1 times 2 is 2. All right. So that would be our answer, negative 2. All right. Excellent. Very good. And I think that pretty much wraps up lesson 14. So again, the only thing I might throw out, and I didn't really mention this, was the fact, and this might just help you understand later too, when we're talking about these variables x, y, z, m, whatever it might be, the reason we call them variables is because they vary. You might have noticed when we were doing those problems, depending on the problem that I was doing, x was a different number. In some problems, x might have been a 1. In other problems, x might, be a 2. X might be a 3. All right, so that number hiding behind the x depends upon the problem that we're looking at. It varies from problem to problem. Okay, it's not always going to be a 2. It's not always going to be a 1. It's going to be any possible number. It's going to change based on the problem. All right, so that's why we call them variables. They vary. Now, if in contrast, if we take a numeral like 3, 3 will never vary. In any problem you give me, if you write a 3, it stands for 3. It's always a 3. That's not going to change depending on the problem. It'll never change. It's always 3. Variables, though, do change from problem to problem. All right, and that's why they're called variables. Variable varies. It changes. That's what the word varies means. It changes. All right. So just a quick note on why we call them variables. All right. So that should pretty much wrap up lesson 14. Go back to OneNote and look at your homework for the week or for the day and start working on those.